afternoon, and welcome to both our in-person and online presentation. My name is Daphne Cook, and I'm delighted to welcome you to the 13th presentation of the Hubbard Sustainability Series. The goal of the Hubbard Sustainability Series is to showcase dynamic sustainability experts to the entire community. To achieve this goal, MCC has developed a series of presentations, and each is featuring sustainability superheroes. These presentations are provided to the public at no charge. I'd like to give a special thanks to the trustees of the Claire M. Hubbard Foundation for providing the resources necessary to support this important endeavor. Your generosity is much appreciated, so please join me in thanking them for their support. I'd also like to thank the MCC IT staff for making today's event possible in a variety of platforms to our viewing audience. Today's topic is sustainable building construction. Buildings are a part of our everyday life, and how they are constructed has multiple impacts on our environment and actually on our human health. And that goes from what materials are used to how they operate. According to the World Economic Forum, buildings account for almost 40% of global greenhouse emissions. Construction also produces significant waste, and the materials in buildings actually impacts human health. Sustainable buildings can affect the amount of emissions produced to create healthier spaces for the people in them. Today, you'll hear about sustainable building trends and technology and review a sustainable building because we'll provide a tour at the end. So for our agenda, per usual, we're going to have both presentations. Then that will be followed by a break for questions. If you are watching us virtually, feel free to go ahead and drop questions into the chat at any time because the chat is being monitored. And if you are in person, you should have received some index cards on your way in. If not, just ask for one from Monica over there in the blue shirt, and she'd be happy to provide that for you. We'll take a break for about 10 minutes after the presentations, and then we'll come back and we will have our Q&A. And after the presentations, we will have a tour of the sustainable housing. But first, let me introduce our first speaker. Her name is Patti Lloyd, and she is the Director of Sustainability at Leopardo Companies of Northern Illinois. Patti has more than 15 years experience advancing sustainability in the built environment. She is an advocate for green building and healthy, high-performing construction. She provides directions to owners and colleagues and subcontractors in planning and execution of healthy, high-performing projects and other sustainability services. She has served in several leadership roles in the green building industry, including as a former board member and chair of the Illinois Green Alliance. She currently chairs the USGBC Materials and Resource Technical Advisory Group and volunteers on several working groups and task forces, including the U.S. Department of Energy Embodied Carbon and Net Zero Building Task Force, the City of Chicago Decarbonization Task Force, and the AGC Climate Change Technologies and Program Task Force. She holds the following accreditations: LEED Fellow, LFA, and WELL AP. She is currently pursuing a master's degree in sustainable management from the University of Wisconsin Extended Campus. Please help me welcome Patti Lloyd.
So what I wanted to talk about as I introduce myself is we're a general contractor based out of Hoffman Estates, Illinois. We have an office in Chicago and Hoffman Estates, and we're currently working all over the country. My first LEED project was in Boston, and currently I've got one in Florida, so we're working all over the place. When I started in this field, actually I've been at Leopardo for 18 years, and I was a temp administrative role when I started. And I like to point that out because it shows how far the industry has come in the last 20 years. when I started and I was working on our first sustainable project at Leopardo, companies did not have roles like mine, Director of Sustainability. I could probably get a job anywhere right now being a Director of Sustainability, because that's how much the industry has moved and gone forward in the last 20 years. And it's a really exciting time to be in sustainability right now, because there's some amazing forward momentum happening with the ESG movement and with a lot of the state and federal movements towards decarbonization. So we're going to talk about, I talk about all kinds of sustainability stuff. And in my job, I actually work a lot with third-party rating systems. So I actually have never built anything in my life. I do go out to the job sites and make a nuisance of myself. But I'm doing third-party rating systems for green building or health and wellness. So I do a lot of documentation. I work with design teams and owners. And one thing that's just been a really hot trend the last few years I say it's coming down the tracks fast, is this concept of embodied carbon. And so we're going to give some definitions. We're going to talk about operational carbon, embodied carbon, and then this concept of total carbon, so that you guys can better understand how it's becoming defined right now. So operational carbon, which I see now that my slide is slightly out of order, but anywho, we're going to go for it. Actually, no, let's go forward one. Okay, so what is carbon? So the word carbon has been used a lot lately. It's a big buzzword, but what does it really mean? It's a proxy word, right? It's used to describe all the global greenhouse gases that are causing climate change. Carbon is not the most prolific, nor is it the most powerful, but this is the term that we're using to describe it. So when people are talking about drawing down carbon or decarbonization, it's not just carbon that we're trying to draw down. And then decarbonization, obviously we want to remove carbon from the system or remove these emissions of greenhouse gases. Embodied carbon is the gases emitted to the atmosphere through the growth, mining, extraction, manufacturing, and transport of goods. And so it's basically like the operational carbon of an item. So concrete is a material that has a huge embodied carbon footprint. And we're going to talk about that more. Operational carbon, that's the carbon your buildings are using. So your heat, your water heating, your lighting, all those things, that's operational carbon. And then what's a net zero energy building? I'm not really here to talk about net zero today, but let's hit it anyways, because it's a pretty low carbon building, right? So it's a building that produces at least as much energy as it consumes. So it's bringing it to a net zero source energy. And then electrification. This is a huge part of what's happening in the decarbonization movement, is divesting from fossil fuels, moving more towards electrical, because the grid is going to become cleaner as there's more renewables brought online. So electrification is a way to decarbonize as well, even though, as we know, a lot of the grids are still real dirty, but they're going to get cleaner as we go forward. So now I want to skip back to this other slide, which is kind of like the embodied carbon, operating carbon, total carbon picture. So as building codes advance and green building systems have greater, lower thresholds, the operational carbon emissions of buildings is going to become less and less and less. So it's going to take less energy to run a building. So as that part of the pie comes down, then you've got your embodied carbon, which is still here. So, and eventually embodied carbon is actually going to become a bigger carbon contributor to the building stock than is operational carbon. And so that's why there's this big focus on embodied carbon at this time. And you can see here by 2040, sorry about that, I just grabbed the mic on accident. Embodied carbon is anticipated to be 57%. So at that point, it's anticipated to be greater than operational carbon. This is for new buildings. We know that existing buildings aren't going to be there yet, right? All right, so Daphne stole my thunder a little bit. She was already throwing out some of these great stats. This is from the Architecture 2030 website. They have a lot of great resources on embodied carbon. And you can see that 28% of the current global carbon makeup is from building operations. But then 11% is from building materials and construction. So that's a pretty significant. As a contractor, that's where I can say, hey, we need to take some responsibility. We have some externalities to our operations that we can address. Of that 11%, 3 materials are what I call the big hitters. Concrete, steel, and aluminum have the highest embodied carbon of any other construction materials out there. So as an industry, if we could dramatically reduce the embodied carbon of those 3 materials, we could bring that 11% of the embodied carbon in building construction contribution to global carbon down. So as a commercial contractor, we have a lot of impacts. We run heavy diesel equipment that emits particulates to the air. We are often involved in land use conservation, from prime farmland to a building, or from a greenfield to a building. And also everything we use is from the earth in some way. It's been mined, it's been harvested. So there's a lot of impacts, and a lot of the rating systems and things out there aren't aimed at the contractor, they're aimed at the building design. As a contractor, I actually don't design or create green buildings. There's a mechanical engineer, there's an architect, there's a whole team of people that do that. So how can we, as contractors, take better responsibility for our impacts on the job site? So one of the cool parts of my career is all the different peer groups that I've been able to be in. And I'm in a national one from this group called Building Green, called the Sustainable Construction Leaders. And that's a national group of people in my role from contractors around the nation. And so it took us about 3 years, but we created this contractors' commitment to sustainability. And it's a free platform that any contractor can get on board with. You can get on publicly, or you could anonymously join and say, hey, I'm going to use this framework as a benchmark to help onboard us to sustainable job site operations. So last year was the first year. I think we had 12 firms sign on publicly. And we went through, everybody had to go through the actions and report. And one of the was the carbon, as you can see. Now this is on a good, better, best continuum, because we know there's contractors, global contractors like Skanska and Turner that actually have whole departments of people working on embodied carbon or operational carbon on their job sites. So they're probably in the best, but there's a lot of companies like mine that are first generation, family-owned companies, privately held, that don't have those types of resources. And so how do you get on board? This framework helps someone say, okay, we're just gonna go on and we're gonna achieve the good level as our starting point. So we felt like this was really successful, and it's only aimed at things that contractors can do on the job site. So this has been a really exciting thing, and I'm really proud of the work we've done. We're reviewing it this year and adjusting it. But it includes things like having limited idling on the job site, using tiered emissions standards. So you've got newer model engine standards on the job so that you've got less particulates going to the air. And then there's some tools out there. So it's kind of started to create this cottage industry of softwares and platforms that can help contractors. So Green Badger has a job site sustainability portal where we're going in and we're entering like our utility bills, vehicle tracking from the job site, different things. And then it's helping to create basically a carbon footprint of the job site. True Carbon's another platform out there, and they're using, I haven't used that one. Some of the bigger contractors are, it's a little bit expensive, but they're also doing similar, but they're really lining it up so that, hey, if you use our program, you can then use our outputs to do ESG reporting, which is a really big thing, environmental, social governance, which is probably really strikes home to all of you here in Omaha right now, as Berkshire Hathaway is having, you know, their big meeting. ESG, I'm sure, is something they'll be talking about. So some of the stuff that we can do on our job sites is reduce job site emissions, like I said, limited idling, tiered emission standards, LED temp job site lighting. I started banging that drum probably 10 years ago, and nobody wanted to do LED temp job site lighting. It's almost standard now in our area. Reduce activities that cause emissions outside of the job site. So one of the items that I'm really working on now in a big way is like, how do we salvage usable materials and put them in the reuse stream, which creates much less carbon than recycling. Recycling takes energy, water, it takes all kinds of inputs to make it happen, to reprocess something. But if you can salvage and reuse something, you've saved a lot of energy. And then materials, materials in your sphere of control. For instance, my company has self-perform departments. We self-perform painting, carpentry, drywall. How can we make sure that we're trying to purchase low carbon materials with a lot of recycled content, or when we're value engineering, which anybody that's been on a construction site knows, I always say, like, the good green things get cut from the job, right? Oh my gosh, that's too much money, we got to cut it out. So how can we protect the healthy, sustainable materials from the job? And then how do we know what's low carbon? Like, how do we know? So this is a EPD, so an environmental product declaration. This is a deliverable that comes out of the formation of a life cycle assessment. So a life cycle assessment is an assessment from cradle to gate of a project's or of a manufactured product's impact on the environment. They're looking at 5 categories. I can never remember them all. Global warming potential, greenhouse gas formation, smog formation, eutrophication, abiotic ozone depletion, something like that. So they're benchmarking. This is not a life cycle assessment, and an environmental product declaration do not mean that it is a sustainable product. It means they're benchmarking. So we've all heard the term, you can't manage it if you don't measure it. This is the first step of measuring. It's a disclosure document. So once you have an environmental product declaration, then you can start to compare it to other ones to try to get a low carbon product. Another note on EPDs, these were first introduced in the LEED rating system in 2012. At that time, it was hard to find products with an environmental product declaration. At this time in commercial construction, I think the LEED point says, oh, you have to have 20 EPDs. I can usually get 40. There's market transformation has happened now over the last 6, 8, 10 years, and you can easily find lots of products with the EPD now. Yep, this is for cold form metal framing. Like, we use this product all the time on our jobs. But the other thing about EPD is it's a third-party verified document. So Patti can't come in there and greenwash it and say, hey, I've got a great product, right? Use me. So that's the other value of it. But this is where I see one of the problems. It only covers the boundaries of A1, A2, and A3 of the life cycle of a product. So it covers from the time it's mined and harvested till it leaves the gate of the manufacturer. So cradle to gate. So it's just the scopes A1, A2, and A3. And you can see after that, there's a lot of life cycle in a product still left. From the transportation, the use, the decommissioning or end of life, and then where does it end up? So what we're measuring is only a fraction of it. The other point that I would say about the environmental product declarations is that's how they're getting carbon data on materials. So on this next slide, this is the EC3 tool. It's a platform. It's called the Embodied Carbon in Construction Calculator. And this is it's such a hard tool to use. I tried to self-teach myself it. You really can't figure out how to use it till you're on a project and using it. But clients are now starting to say, hey, we want you to tell us what the embodied carbon is on your project. Now, the designers are being asked this too. They're using some different tools like Tally and one-click LCA, but what's designed is often not what's built, right? We change materials, things change. So this gives us an opportunity to select the lowest carbon material under our control, and then we have to report that to the client. And there's also rating systems about carbon. There's 2 different zero carbon rating systems. So the EC3 tool, this is, I put in 3,000 PSI concrete in my area, and I said, okay, I want to see what's the lowest carbon mix that I can get. And I think it's the second one. Yeah, so you can see the one that's coming in at 231. It's one manufacturer, 2 different yards. But contractors are using this tool to select the lowest carbon materials. Right now, there's about 10 key materials in the EC3 tool, and it's taken about 5 years to get to this point. Every year they on-ramp a couple more materials. But any firm that has an EPD loads them into EC3, and then that's how that carbon data is derived, so that I can look at it and say, oh, I'm going to use this one from Prairie Materials or whatever. So there's a lot of green building rating systems, and green building is decarbonization. If you are reducing your energy use, you're decarbonizing. If you're buying materials that are considered low carbon, you're decarbonizing. So I'm just going to talk about a couple of these. These are rating systems I work a lot with. So the U.S. Green Building Council has the LEED rating system, Leadership in Energy and Environmental Design. It's by far the most predominant rating system globally. Enterprise Green Communities, the rating system we're using a lot on affordable housing projects. NGBS, National Green Building Standard Green, that's also for affordable housing. Green Globes is similar to LEED. The Living Building Challenge is the most stringent green building rating system in the world. And then Passive House. So Passive House is only about energy efficiency. And I think that's an important distinction. When I look at Living Building Challenge, they're going to require you to be net zero on everything: waste, water, energy, and in some cases regenerative. But in addition, they've got the red list, which is over 800 chemicals of human concern that can't be in the materials. And there's big social equity pieces to the Living Building Challenge. The LEED rating system has all the decarbonization stuff, but it also has stuff about health and wellness, like indoor environmental quality, having low emitting materials in the building. Passive House is really interesting because it is 100% about energy efficiency. They don't really care if you have a known human carcinogen in your insulation, right? They just want to know that you're getting like the lowest possible source energy use. And then there's some zero rating systems that are all about net zero energy. And I put these up here without really focusing on the zero carbon rating systems, because the zero carbon rating systems have not had a huge amount of pickup. We bid one for Salesforce. We've all heard of Salesforce, and we lost it, but that one was going for zero carbon. There is a zero carbon project in London, the Pancras Square, but there's literally just like 2 or 3 zero carbon certified projects. So I think, focusing on zero energy is probably more socially acceptable and palatable to the building and design industry. So you've got Passive House Zero. You've got Living Building Zero Energy Certification. LEED has a zero energy rating system. And then there's the Zero Energy Ready Home rating system. So there's a lot, people say, oh, zero is like, it's an outlier, nobody's doing it. But I go back and say, really? Because I can tell you like 5 rating systems right now that are working on zero. So I beg to differ, it's coming. This year we've bid on 4 zero projects. Last year we had none that we bid on. So, I had a couple more points. These are all different though. So 2 of them require a year performance period. I emailed somebody yesterday and was like, hey, can we tour your Living Building Certified Zero project? And they said, no, because we're not certified yet. We have not been able to prove that we're net zero energy over a 1-year performance period yet. So that's a big deal. 2 of them do not allow combustion. So no gas-fired anything. Can only be electric. So I think those are important parts. And also say like, okay, these are how these rating systems are addressing zero. Carbon sinks. So what is a carbon sink? Carbon sinks are things that can absorb carbon from the atmosphere. And so oceans and forests are the two biggest carbon sinks we've got out there. And as we cut them down or destroy them, then their ability to process that carbon from the atmosphere and to reduce the Earth's global warming potential becomes less and less. And so I always like to point this out here because, you know, I'm in construction, like sometimes we're cutting down trees to do what we do. The oceans, people don't think about it, but all the carbon in the atmosphere is actually settling into the water, and there's a chemical reaction that's taking place that's causing acidification of the oceans. That's why the coral reefs are starting to go south. So protecting these carbon sinks is a really big deal. Pretty much all the rating systems have sequestration credits. So can you plant trees? Can you invest in things that are going to sequester carbon? There's also carbon sequestering concrete mixes out there. Carbon Cure, we're using it on a job right now. And there's also a lot of programs out there that are supporting preservation of these sinks through offsets. So that's how like the red REDD plus came in. That is developing because, you know, unfortunately, most of the rainforests and the really powerful carbon sinks are in developing nations. And those are the areas that like need to harvest those things the most so that they can become a developed economy. And so it's a real push-pull. So programs like Red Plus are paying them not to deforest. There's also programs called Paying for Environmental Services that are also helping. In our part of the country, we're more familiar with things like conservation easements for like wetlands and watersheds, endangered species, and so forth. So I just always like to point this out. These are really important. So decarbonization. So I'm like trying to bring this back to like what you can do in your life because I'm not sure that any of you are commercial contractors, right? So the things that I can do to decarbonize in my work life are probably not things that you can do in yours. So calculate your carbon footprint and then take action. You can do this on your own home with your energy usage. The EPA has a great little carbon footprint calculator that you can use, and you put in your utility data and your driving data, and you can get a baseline. And then once you have your baseline, you know, you can start taking actions to bring it down. So we're super cheap, me and my husband. We hate spending money. But we're also very sustainable. So, you know, every year we do a project, and we've been doing this for years and years and years. One year we did attic insulation. One year we sealed up our basement. One year we got 33 solar panels. Obviously the projects are getting bigger as we go, but it's not a sprint, it's a marathon, right? So figuring out what you can do and then moving toward it. There's so many things you can do at home that aren't renewables or even things to your home, things like about how you live. Reduce your transportation emissions. So transportation emissions are one of the biggest pieces of that carbon pie that we saw earlier. So how can you reduce your transportation emissions through public transit, trip chaining, getting fuel-efficient vehicles? Food. So if anybody have read Paul Hawkins' book, Drawdown, you would see that the three biggest known carbon drawdown solutions now that we can do now, not a silver bullet, not something that somebody needs to go invent to save the day, the refrigeration management, offshore wind, and reducing food waste. Okay, so all of us can reduce our food waste. That's a big deal. Spend wisely, vote with your dollars for companies and firms that, you know, are walking the walk, not just talking the talk. Reduce your waste, like your real waste, your waste to the landfill. Take it to work, play, and otherwise influence others. I actually love talking to groups like this. Like, I talk to a lot of groups of sustainability professionals. That's great. They all agree with me, but I'm pretty much preaching to the choir, right? So talking to groups and influencing groups that might not share your views but can understand either the economic impact or otherwise is great. And then unite behind the science. Like, don't engage in divisive or political drama. I can tell you, like, as a sustainability professional that grew up in Oklahoma, like, all my friends, families drill oil. Like, so when I go back home, they're like, you're trying to take our jobs. No, we are going to have a just transition, and we're going to, transition our country's energy usage in a good way. So I got carbon offsets for this flight today and for a flight I'm taking later this month. When I was talking about the carbon sinks earlier, that's what offsets will support. So only one of the 3 zero rating systems that I shared with you earlier will allow carbon offsets. But a carbon offset is going to offset your transportation emissions. So airline emissions are particularly nasty because they're let out at such a high altitude. It's like if something's emitted at ground level, it gets a lot of dilution before it gets up to the top atmosphere. But airline emissions are shot right up there in the upper levels of the atmosphere. In addition to that, there's another chemical transformation that happens that makes some of those other chemicals really nasty. So it's more impactful than like auto emissions. So getting carbon offsets is a great way to go. I spent $18, 27 trees. So I always like to have like a call to action or inspire people and give them a little hope. When I finish up my talks, people always say, well, I'm just one person. I can't do anything. It doesn't really matter what I do. Or if like you're my parents, you say it doesn't matter what I do because I'll be dead before any of this matters, which I think is like a terrible attitude. But I like to talk to groups like this because it does create the ripples. I speak with a lot of youth. I'm a merit badge counselor, and I do those things because I think that I can influence people to embrace a more sustainable way of life. And I've been watching recently like the little Greta Thunberg series, and there's a great example of one person having an outsized impact. None of us need to have an outsized impact. If we can just at least take care of our own impact and maybe bleed over a little bit to others, I think that's a great starting point. And I'm not saying any of this to be lectury. We all have our green guilts. Like none of us are perfect. I live a pretty sustainable lifestyle, but I've got, a couple things that we do at our house that, I wouldn't want everyone to know. Like we use disposable flossers. But anyways, everybody's got room to improve, even me. Here's my contact information. Please feel free to reach out if there's anything of interest. And I really thank you today, and I look forward to your questions in the Q&A.
Thank you so much, Patti. That was wonderful, very informative. Now I'd like to introduce our next two speakers. These two speakers are some of MCC's own extraordinary superheroes. Dr. Berry is currently the Dean of our Career and Technical Education at Metropolitan Community College here in Omaha, Nebraska. And prior to his current role, he spent 8 years as program coordinator and assistant professor of construction management at the University of Nebraska, Kearney. Before joining academia, he spent career in the construction industry, beginning as a laborer, superintendent, project manager, and business owner, all in the Kansas City metro area. Dr. Berry has published over 12 articles in reference journals and proceedings, and he has been invited to speak at over 50 events across the nation addressing the changing workforce in the construction industry and its effects on quality and sustainability. Dr. Berry has been awarded the National Excellence in Teaching Award by the Associated Schools of Construction, as well as an Outstanding Educator of the Year award by the National Association of Home Builders. Most recently, Dr. Berry was named one of Midland Business Journal's 40 Under 40 business leaders. Corey Woods is an instructor at Metropolitan Community College in the Construction and Building Sciences program. Corey has worked in the construction industry for over 27 years in residential and commercial and civil construction. He started in the construction industry as a general laborer and quickly moved through the ranks, becoming a carpenter, leadman, foreman, project manager, and an estimator. He has helped bring sustainable construction projects to the Construction and Building Sciences program at Metropolitan Community College, including the Sustainable Small Home that you will all be seeing later that was built in collaboration with the University of Nebraska. Corey earned an Associate's of Applied Science at Metropolitan Community College, so he's one of our own, and also a Bachelor of Science from Wayne State College. Now I give you Dr. Berry and Corey Woods. Thank you so much for being here today.
Perfect. Well, thank you so much. I am really excited to talk about sustainability in the construction realm. And let me tell you, the conversation we're having today and what Patti presented, that wasn't even on our radar when I entered the industry 20 years ago. So just to know that we're having conversations about this in just a short 20 years. So I'm here today to talk about sustainability in the housing market and why we should care. And then I'm going to turn it over to Corey to really talk about what we're actually doing here at the college and some exciting things. Sustainability in housing, why we should care. And I think I would like to talk a few minutes about the history of our housing stock in the United States, because the reality is we've got about 140 million homes here in the U.S. 84 million of those were built before 1979, and that's a big number. 1979 was a big year because before 1979, it was the Wild West in construction. And why we care so much that 60% of our housing stock was built before 1979 is because we're replacing homes in the U.S. at a rate of about 1 million homes a year. And that's great, right? Except we build homes today to last 100 years. We have a huge housing stock that we need to work with for a long, long time. And of course, we've been throwing out a lot of numbers. Residential specifically is using a large energy consumption and of course, having that big carbon footprint. So why is 1979 so important? 1979 was the year OSHA began. And before 1979, anybody could build anything with no regards to safety or anything else. So when we're talking about the housing stock, the actual International Code Council wasn't even formed until 1994. Think about that. That was not that long ago before we even started to have conversations about standardizing the building practices that we now use today. And actually, the first international residential code wasn't even published until 2003. That should be alarming to everybody, that we have not actually talked about standardizing building construction in this country until 2003. But again, that's a policy that was made. Now we allow municipalities to decide if they want to enforce it or not. So every city, every community, every state can decide not only if they want to enforce it, but then as the book gets updated every 3 years, what year they want to enforce. So we still today have states and cities and municipalities that aren't using any residential code, some that are still using 2003, some that are all the way up to 2018, and then the new book 2021, which nobody's even adopted yet. The big thing about the building codes and standards, it was really based on occupational safety and making sure that the home would stand for 100 years. It wasn't actually until 2006 when they started to talk about energy efficiency because of the impact that residential houses have on our energy today. So, and actually that kickstarted in the 1970s oil embargo, so about the same time, but energy wasn't even addressed in the codes until the 2006 code book. Since 2006, we've realized the impact that even the 2012 update, so just in the second update, had a 33% reduction on energy usage compared to the 2006 houses. So we are making great strides very quickly in making sure that the way we build homes today is not only safe and going to last, but are actually really, really energy efficient. So we're doing a great job today. I kind of like that. Patti talked about the commercial sector, but the residential sector actually uses more energy consumption than all the schools, hospitals, and buildings that are up today. Let's talk about maybe why that is. So we should be proud about the energy codes we have today in place. So we've solved the problem, right? We're good. The challenge is implementation, isn't it? The challenge is implementation, especially when we talk about the residential housing sector. When we just look at the market itself, when we talk about commercial buildings, the top companies in the commercial sector build about 50% of all the buildings. So the big companies, the Kiewits, the Turners, the McCarthys, all the big top 400 commercial contractors do about 50% of the billions of work in the US. And that's not surprising because it takes a lot of manpower to build those buildings. When you talk about the housing sector, 95% of all of our houses built today are built by companies with 10 or less employees. Think about training. Think about implementation. Think about how to get 95% of small businesses all to walk and march in the same direction. So even though we have building codes that are so much better than they were even 3 years ago, implementation and training into these smaller companies is really difficult, especially when you talk about profitability and all the different challenges that the housing market has today. And then we talk about just barriers to market implementation, right? So that's great. You get a builder that says, I'm all in and I want to build even zero net energy homes. Well, guess what? The customer isn't always willing to pay for that, are they? And if they are willing to pay for it, will my insurance company cover those solar panels that I want to buy, right? Will the appraiser give me value for the sustainable things I did? Because I can tell you right now, the appraiser is going to give you more value for the tile in your bathroom than they will the extra attic insulation or the sustainable lumber you decided to use. So we have all these market implementation issues that we're kind of addressing right now. So I say that because even though the codes have kind of caught up and we know what to do, it's doing it that's taking a lot longer than it probably should. But we are making some strides. A number of states, in fact, all but a few in the Midwest, have adopted at a statewide level some type of residential energy code. So there is now the IECC, the International Energy Code Council, which kind of coincides with the International Building Code and the International Residential Code and the International Plumbing Code and all the other ones. Most of the states have adopted at least some type of energy code to be implemented in that state. So we are heading in the right direction. So we've got a lot of promise ahead of us. What we're doing here at the college and what Corey's going to talk about is what we see as what's the next iteration, right? What's the next generation of sustainability? And we're really excited to talk to you about today about the granny pod, because that is an idea that is not just let's build smaller, tiny houses, but actually how can we build a healthier home and extend the life of a lot of our citizens as we talk about an aging population and that kind of stuff. So there, I gave the quick history lesson. Corey's going to talk about kind of the future coming up. So it's all yours, Corey.
So I'm a little bit less experienced. I'm not 50 events under my belt. This is my very first one, so bear with me a little bit. I do have some things written down here that I'll probably read a little bit off the cuff. So the Granny Pod is a sustainable small house. So between University of Nebraska and myself, we call it the SSH, Sustainable Small House. So first off, the players that kind of came up with this. So Dr. Bing Chen, this is pretty much his baby. He's kind of worked on the concept and the idea for the last 7-8 years. He's the one that approached Metro Community College about doing this collaboration. Brandon Kryling is the assistant professor in the construction engineering program at the University of Nebraska. And he is kind of their project manager, kind of helping out with Dr. Chen. And then Stephen Eggerling is also with the University of Nebraska, and he's the one that kind of did all the drafting and the design work and kind of helped put it all on paper so we can make it happen. And then, so what exactly is sustainable construction? We've been kind of talking about it a little bit. Some things that I just kind of like to talk about is sustainable construction is the practice of creating a healthy environment that's based on ecological principles. So sustainable construction focuses on 6 principles: conserve, reuse, recycle, renew, and protect nature, create non-toxic and high quality. The goal is to reduce the industry's impact on the environment by utilizing sustainable development practices, employing energy efficiency, and taking advantage of green technology. Like Patti said before, concrete is one of the highest carbonization products that we use. Concrete is also the #1 product used in construction, is also the most expensive. So that is kind of behind that. Some of the materials and things that we use, we can start using like recycled materials. There's a lot more of that actually being used today. So different types of sustainable construction that can include anything between construction techniques, resources, and building practices that have evolved over the years with increased interest in sustainability and energy conservation. New methods of construction that focus on sustainability have been developed. There are 2 things that go into sustainable construction: the materials that are used and the methods that are utilized. So when we talk about some of the methods when it comes to residential housing, we talk about what's called the building envelope, and creating a sealed building envelope will help reduce energy loss. Everybody has probably been in an older house where you have been next to a window during the winter when it's cold, and you can feel a draft physically coming through it. Some of the older generations used to put plastic film over their windows and things like that. So what we're trying to do is prevent that energy from going in and out of our houses. So we talk about the thermal envelope or the building envelope, and that is considered anything from the bottom all the way around surrounding the entire living space. So we're talking about attic insulation. Like Patti had talked about earlier, they had done attic insulation. That's something we can do to help lower our energy losses. Our insulation that we do in our walls themselves, something that I'll talk about with that is how we actually built our walls in the house itself. There's different ways that you can do that. We talk about thermal transference through our actual materials. So traditionally in the past, houses have been built with OSB sheathing and then some sort of finished siding that attaches directly to a stud member, and that stud goes through and touches the drywall that's on the inside of the house. So the cold air or the hot air that's actually outside, that actually thermally can transfer through that materials. So what we need to create is some form of thermal break with that. So there's a couple different things that we'll talk about when we do our tour over there that we actually did to create thermal breaks. One of them was creating a staggered stud pattern where we have basically 2 stud walls for our exterior wall. That is one method of going about doing it. Then we can also use what we call a zip wall system. That's a newer product that we're seeing a lot more usage of, that actually has, instead of just the OSB sheathing, it creates and has 1.5 inch foam insulation that attaches directly to it, creating the break on the outside, preventing that cold air and heat from transferring through. Other things that we take into consideration, obviously, is going to be any kind of lighting using lower voltage. Solar panels up above on our roof is what we have actually that we're using on the house. I have a slide here that'll show you what we're using. It's actually a newer product. When we talk about net zero, talked about, I think Patti brought that up earlier, where we're producing as much energy that we're going to use within our house or more. So this house itself is actually designed as a net zero house. The solar panel system that's on this house will provide more than the energy that we need to provide power to this house. It could actually lose sunlight and everything 100% for about 48 hours and still have everything working 100% operational, full blast, and still operate for 48 hours. So the actual, let me get to the next portion here. The granny pot itself, I'll talk about that here. This is a nice picture of it. The studs that we talked about, we had built a staggered stud system. So if you look very closely on the very bottom plate, you can see that we have 2x4s that go along the front wall, and then we also have a set of 2x4s that go along the back side, so on the inside. So what that allows for within our wall system is that it also allows a thermal break. If we had one stud that runs all the way through, kind of like you see on our door openings, because that's unpreventable because we have to have bearing, so that creates structural issues. With that, that creates the allowance of having foam insulation to go all the way through. So that prevents a thermal break right there, or thermal transference right there. Here is a picture of the overall solar system that's on the top. This is actually a brand new product to the United States. It's only been used, I think, on a couple different houses in California. It is from Thailand, and it is an actual corrugated metal roof that has these solar panels directly on them. So in this aspect, everybody's seen the traditional solar panels that have the big glass, the bulky ones that go on the actual top of the house. In this case, they have eliminated the glass portion. This is 100% just a corrugated metal, just like you would see on a barn, houses and things like that. And it just has the electronic component directly on it, and it has a coating that is actually over the top to prevent damage from the elements, from frost, freezing, hail, and things like that. So that is the product that we are using. They have run into a few little hiccups that have to do with the state inspection, but I think they're working on that as well, just because it's a new product to the United States. So of course, everything in construction has to go through its proper testing channels and everything like that. So part of what the purpose of this house is actually creating an experimental type of situation. So the intent that Dr. Chin had behind this house, as we called it before, was a granny pod, right? So the intention behind this is that it's going to be 100% technology driven. The intent is that it will meet the needs of older and aging citizens that are nearing retirement age, that are retired and are nearing that point where they may need some assistance close by. They still want to retain some independent living. They don't want to feel like, oh, I'm taking up my children's house and feeling, you know, kind of like a burden in some manner. So the city of Omaha has actually passed what they call ADUs, which is alternative dwelling units, and that's what the granny pod fits. This is new to Omaha. There has not actually been a permit. This is something that was passed during the COVID shutdown. However, there's a corridor along Dodge now that has been approved to allow the usage of this. There's still some hiccups that kind of go on with getting the permitting process done, so there has not been anything built just yet, although there are a couple places here in town that are actually working on getting those even easier to use. So the intent behind this is that you can actually have your parents living in a separate house on your same property. So they're close by. If something happens, they retain their independence. They're in their own living quarters. You can kind of maintain that independence from each other. But yet, if something happens, you can be right there to take care of them, call the ambulance or whatever needs to. The technology portion of this is also talked about because Dr. Chin likes to think about what can we do electronically. Everybody has Siri and Alexa and everything right in their pocket, right? So the advantage of that is Apple actually has apps where you can set up emergency situations. So your phone can sense if you fall over and some sort of emergency situation is happening. The issue is a lot of our older generation doesn't necessarily know how to use the technology. So the intent behind this is that they're also going to eventually implement some sort of sensor technology in the floor systems where if there's a fall or something, the sensors in the system will actually alert a computer system within the main house saying, hey, something's wrong, please go check on the folks in the house. So that is the other intent of this. And also then the very end of that is the ADA compliance. Everything we have used within this house is considered ADA compliant. That is also something that is a little bit of a challenge in residential construction because not everything is ADA compliant. When you think about two-story houses, how would we get somebody up and out with a wheelchair going up 2 floors? So things like that are addressed. Also just going over thresholds. Everybody's gone in and out of thresholds of your houses. If you think about trying to push a wheelchair over some of the exterior door thresholds, you will notice as we walk through the house out here in the lab that we have ADA compliant thresholds. That is actually a little bit more expensive to go about doing. However, the thresholds are only about 1/4 inch to 1/2 inch. So that allows them to be able to push wheelchairs and things like that across that as well. This is just kind of a rendering of the interior. The interior is still being worked on, so obviously this just kind of helps you have a nice visual feel for it. And then we have the bathroom, which will actually end up having it could have a composting toilet. In this case, we're using one with a bidet, and it actually has a sink that you can actually pull away from the wall and put in front of you and then move back. This allows that in case somebody who is in a wheelchair or something like that, you can move it around. They can be on the toilet, use the toilet, wash their hands, finish up whatever they need to, and or if they're in a wheelchair, they can also pull the sink to themselves, and then it's also being pushed back out of the way to allow them easier access in and out of the bathroom. The location of where this is going, so I'm sure everybody's kind of wondering where are they going with this. The intention is that the University of Nebraska is going to actually have it sitting on their property on the Baxter Arena. For those of you that are familiar, that's just south of the Exarban Village. The Baxter Arena we can see is right up here. And currently they've been building the last couple of years a baseball field right here off to the left. And where my little white marker is at is going to sit up on the hillside overlooking the baseball fields. The intent is that the electrical engineering department and some of the other departments at the University of Nebraska is actually going to monitor it for its energy efficiency because nothing quite like that has been done before as far as just monitoring it. The intent behind this is that he wanted to be able to change the actual heat register inside of the house with 16 candles. The intent of this was designed around his great niece having a 16th birthday within the house and being able to light the candles and physically be able to alter the temperature in some manner with just 16 candles. So this is something that he has called a tiny house built on steroids, is essentially what he calls it. So it's way overbuilt for what it is, but that's kind of the intent behind this, is to see how far can we take it and how far can we actually make it environmentally friendly. And then you can tone down, obviously, because when it comes to residential, we talk about equitable and equity. How can we make this more affordable to everyone is obviously the biggest portion. One other thing that I just wanted to touch base on is some of you may have heard of the Sienna Francis House here in Omaha. They work with the homeless population and things like that, and they have programs that help get people readjusted and back out into the community. The Sienna Francis House is actually bringing the very first tiny home village to Omaha. They have actually officially broke ground on it now. We have been building 7 of the 50 tiny homes that are going to be a part of this. And what it is actually it's designed to allow people who are entering the graduate portion of the program to have their own individual space. These houses are about 255 square feet. They have 2 rooms and a little kitchenette and a bathroom. So there's a little bedroom and a living room. And they will pay about 30% of their income as rent and become a little bit more independent and getting ready to step out back into the working world. So we have been blessed with being able to build about 7 of these. We have 5 of them that are nearing completion. When we go through the lab over here, we have 2 mock-ups that we built just for the engineers to just kind of take a peek at.
Corey Woods and Dr. Nathan Berry, I just want to thank you so much for that presentation. And I don't know about you all, but I have questions. And so I think you probably have questions as well. We are going to take Okay, I'd like to thank you and welcome you back after our break and our discussion on sustainable construction. I also would like to thank members of our audience and our virtual attendees on the chat. You have posed some really great questions for our sustainability superheroes to answer. So Nate and Corey, our first question is, does MCC have any future plans to build more sustainable homes?
Maybe. No. Actually, the answer is absolutely. Yeah. We have a lot of momentum right now. And actually, when you talk about sustainable homes, everything we're doing that's a service project or project-based, we are building to the newest energy codes. And the newest energy codes by themselves are really, really, really close to being, as sustainable as you can get. But we actually have, we are right now developing curriculum to do a sustainable building certificate as part of our construction program here. There's a lot of momentum in the area and a lot of need for that in the area. So yeah, absolutely.
We're also not just doing the construction portion of it. We're trying to work with other departments as well, like bringing horticulture and everything, and culinary arts, because when we talk about sustainability, we're talking about sustainability as a whole, and really our entire life itself. So,
well, and as Patti pointed out, by the time it gets to the construction guys, if we haven't talked about sustainability or made decisions, it's too late. So when we talk about sustainable homes and sustainable projects and everything, that better be a conversation at the very front end of the design, as far as the material selection, the location of the project. By the time it gets to the actual building of the project, if we're starting that conversation there, it's already way too late. So.
Thank you. Patti, what do you see as the biggest trend in decarbonization?
I mean, I think the biggest coming trend, which is what I spoke about earlier, is calculating embodied carbon and selecting low carbon materials. Closely behind that is, or in front of it, I'm not sure, is the net zero buildings. Again, addressing new construction. Existing buildings are going to have a huge amount of attention paid to them. They've basically been the redheaded stepchild all this time. Like, everybody's like, new buildings, let's make our new buildings green. But nobody's really talked a lot about what we can do with the existing buildings. But the greenest building there is the existing building. It's already built. It's already got all that carbon in the building material. So adaptive reuses and figuring out how to renovate or improve existing buildings is just going to be huge.
Well, Nate and Corey, as we're looking at reusing existing buildings, how does that affect residential homes?
Well, I mean, like I talked about with our current housing stock, we have 84 million plus homes that were built before 1979. And the biggest thing we can do are what are considered minor retrofits. For a $1,500 or $2,000 investment, you wouldn't believe the energy improvements you can make in those residential homes. Honestly, 30% of energy use can be saved just through homeowner habits. So there's been a lot of good research done on educating homeowners. So even if you don't change anything physical in the house alone, just educating the user can have a huge impact on energy consumption. And then very minor things that don't change the aesthetics of your home can do a lot. So energy retrofits, I mean, that's a huge thing that we kind of go in waves, right? And I feel like that it's coming back to people are starting to realize for those small investments, a big change can happen. So,
and an example of retrofitting, I mean, you can go through, we were talking about thermal breaks earlier. You can go through on an older existing house and put rigid foam insulation on the outside when you redo your siding. When you go through to replace your siding, and then you can just go right over the top of that. That's essentially what we're doing with new construction. But you can still do that to a house. Obviously, then changing out your windows to more energy efficient modern windows will also benefit.
And really, as kind of a public service announcement, a little bit, a lot of people don't know this. Because people just assume I have an old house, my energy, my utility bills are high. But you really don't know, are they higher than your neighbors? Are they not? And actually, a lot of public power districts, if you feel like your energy bills are higher than normal, you can call them and they'll come out and do a free energy audit on your house because they want us to use less of the product, actually. So they're encouraging us. So if you do feel like, maybe your utility bills are a little higher than your neighbors or higher than they should be, call your local utility provider, and a lot of them will come out and do an energy audit on your house and look at some things and maybe catch some stuff that you might have missed. So
I got to chime in on this. Another thing, and I don't know anything about Nebraska or how you guys are set up, but there's a lot of energy efficiency incentives out there. Just 2 weeks ago, my husband's like, what's this $40 from ComEd? Well, that was our rebate for getting an energy efficient stove. So finding out what's out there from your utility or even federal or state incentives. We just got the 25% federal renewable energy tax break for our solar. We got incentives for our insulation, for our attic ceiling. I don't think we did for our windows, but you can get it for lighting upgrades. So that cost is often a big barrier for people. And so I like to point out the incentives so that people know it's something you can go look for to help offset the cost of your improvements.
Well, I just so appreciate the information and also the education. Corey, when you were describing, that gust of wind coming in your home, I thought about my home that was built in 1922, and I'm like, wait, that's my home. And so, but just those things, as you mentioned, Nate, that you can do to, on your own, to have that 30% increase in efficiency and energy. Here's a question that we have from our chat. Do you think that the metal roofs with the solar panels built in will become more available on a larger scale for more people anytime soon?
I think so. I know that part of the reason why the company is obviously trying to get into the American market is to break into this market and start making this more. We also see the Tesla tiles. That is something else that we're starting to see. So that's actually a clay tile. You would not know that's any kind of solar roof system at all, aesthetically. So I think our products are maturing and headed in that direction, and this is just the start of those kinds of products that we're actually going to see.
I also want to say it's really important that the R&D keeps happening on products like this, because conventional solar panels like I have, there's only a limited amount of the rare earth metals and the resources that are needed to make them. And so we have to innovate to better photovoltaic panels that don't require those materials.
All right, here's another one. Whichever one of you thinks would be best to answer this. Why is carbon the shorthand for all emissions? Methane is a great concern. Should we work to curb all emissions?
Go ahead, Patty. Why did we choose carbon?
I think carbon is just, I don't actually know why we choose carbon. It's just the proxy. It's the proxy word. But methane is by far the biggest one. There was a great article recently, there's a cow-shaped hole in our methane legislature, where the methane, first of all, methane is released and lost during the transfer of gas power. So that's one. Agriculture is another. And then our huge amount of landfills. And then the melting of the glaciers and the ice caps. All those places, there's methane. So I don't actually know off the top of my head why carbon is that proxy word, but it is meant to be inclusive of all the greenhouse gases. Anyone?
Well, no, I just think that's the difficulty, right? Is do you call it global warming or climate change? And I mean, so just the terminology and the education alone is difficult, because there's lots of small conversations happening all over this country, and getting that standardization so we can all agree on where we're headed is difficult. So let's just choose one and go with it, though.
Well, I think a big influence is what can we control? We've talked about methane and stuff, and there's been talk about methane from cows as an example. We can't control that, but we can control what we're taking out of our ground. We can't control our emissions that we're making from making our products. So things like that. I think whatever we can control as people, that's what we need to focus on.
Patti, I believe this question is for you, as you had talked about the airplane emissions in the sky. It says, shouldn't high levels of atmospheric CO2 be good for plant growth?
No, because it's not at the level it's not down in the troposphere, I think, is the level where the plant growth is occurring. It's way up in the stratosphere, so it can't really impact that. There's the fossil fuels lobbied, you could look up stuff from 30 years ago that's greenhouse gases are good because they, promote plant growth, which then takes up carbon. And you could compare that to what the tobacco lobbyists did once they first found out that,
it's a great weight loss supplement.
Yeah, that cigarettes cause cancer. And so, it's an interesting argument, but actually the emissions from airplanes, I would say, are more powerful than ground level emissions, because they are being injected way high up there where they can do the most damage the quickest. And then, there's those chemical reactions happening with the other tailpipe emissions that are also doing damage. So,
Patty, you had mentioned how the forest and the ocean are natural sinks. Well, how does a garbage patch floating in the ocean affect that?
I mean, I think the point to that is that we've not taken care of our carbon sinks. We have not taken care of the important things that are preserving life on this planet. And, you know, there's only a few of them. We need air, we need water, we need food, we need land to live on. If we can't take care of those things, then we're going to hurt ourselves. And I think the Great Garbage Gyre, and there's 5 of them, I think, are a great example of our throwaway, take, make, waste society, right? We're going to use single-use stuff. We're going to throw it away. We're not going to manage our waste properly. But then secondarily, that's part of the deterioration that's happening in the ocean because those things are deteriorating and creating a microplastic problem.
Nate and Corey, I believe this question is for you. It says, explain why concrete is so bad. Oh, for carbon sequestration? I can't quite read the word. But why is concrete so bad?
Okay, so first we think about the process of how is concrete made. What are the ingredients of concrete? Everything that is an ingredient in concrete is mined out of the ground. Every piece of equipment that goes into mining is emitting carbons as well. So we have the use of off-road trucks to go down and get the rock. Here in Omaha, we use limestone. Limestone is a giant bed of rock down below the surface. They go through and they use dynamite to blow that up. They have to have haul trucks and everything to run it up the hillside, and then they run it to crushers, and then it goes through, and then they're being used in a diesel-powered plant that is kicking out emissions as well. So the whole process of creating concrete and how the ingredients and everything are mined out of the ground is the main portion of that. So, Nate, I don't know if you have anything
No,
to add to that.
I think you nailed it, and that's the challenge with concrete specifically, because once it's in place, it's a really sustainable, long-lasting product that can actually help us if we use it correctly with heat energy transfer and a lot of positive things. But getting it in place is so impactful right now. So,
and to defend a little bit of concrete, we do use recycled concrete for a lot of products. Recycling concrete, you can turn around, and a lot of people use it for rock laydowns in construction sites. If you notice on your interstates, almost every state uses the rock or the concrete that they had before on the pavement. They turn around, crush it, and then use it as a base to help support the new pavement that much more. So it's being reused. So they're doing things like that to try and offset that a little bit. But like we said, concrete is still one of the highest emissions.
Nate, I believe this question is for you. Are there any new or future training opportunities MCC is looking to provide to help meet market needs?
You know, that's honestly, that's like a softball question, because I love what we're doing here at the college. We have been really, really good at responding to industry requests or community requests for training, whether that's a weekend, 8-hour seminar, or whether that's a 6-week program, or whether that's a full degree program. So we have a number of them in place, whether that's that we just run quarterly or in the summer. And then also we're really good at taking that phone call. And if there's a small company or a group of individuals that want to create some training, we have an entire team here that develops customized training for that kind of stuff. So
I think we actually have 2, right? Workforce innovation, which is part of what we're doing right now. And then we have corporate training as well that also jumps in.
Well, Dr. Nate Berry, Patti Lloyd, and Corey Woods, I'd just really like to thank you for being here today and providing this information. Before we transition to our next portion, which is a tour of the Granny Pod, do you have any thoughts?
I'm just glad we're back to having these conversations. I feel like there was a lot of momentum, prior COVID, and we were having these conversations, and I feel like everybody stepped back. So the fact that we're here having these conversations again gets me excited about where we're headed. So not only here in Omaha, but actually regionally and nationally. So
I have, something slightly cynical to say, but as we are on the heels of Earth Day, which was last week, it's wonderful. It brings a lot of awareness to a lot of people. It's a little trite to say that Earth Day should be every day, But as a human species, as a developed country, we've innovated our way into this, right? And the developing countries are the countries that have caused most of the emissions. Yes, China, India, the growing countries now are contributing, but what's up there now that's causing the damage is what was put up there by us, by the developed nations. And so we've innovated ourselves into this, and now how can we use the brilliance of humanity to engineer, innovate, and invent our way out of it? Because there's a lot of exciting things happening in the R&D, in construction. Like you said, we're talking about construction. Sustainability, it goes across every single discipline, touches everyone's life. So how can we start to, support those movements? So.
All right. We are going to transition to a tour of the actual granny pod that is here. So the exciting thing is if you're here on site, you're going to walk over and follow our speakers, and they are going to provide you a tour of the granny pod, but you are not going to miss it if you are joining us virtually, because we will be back in 10 minutes, just as long as it takes everybody to walk over, and you will be a part of the tour as well. So we will see you shortly.
One thing I was going to stop and talk about here real quick was I talked about the zip wall system. So what exactly is a zip wall system? This is the sheathing that you see on our capstone house. This is another project that we're working on within our program. This is the zip system. It is OSB sheathing, which it also has the layer of insulation that I was talking about that creates a thermal break. So if we all walk past this, and I'll have the camera kind of zoom past the side of the edge, you will be able to see the foam insulation that I was talking about, which creates the thermal break. So on the sustainable tiny house that we used this same zip wall system that has about an inch to an inch and a half layer of foam insulation just to the inside. So that creates that thermal break from transferring the energy of the cold or the heat from the outside all the way through the material to the inside. So then we'll just kind of walk over this way. We can go take a look at the tiny house, and hopefully we have a little passageway over here. And so what we have right here are the two mock-ups that I was talking about with the Sienna Francis house. Just some visible differences that you'll see. In this set of houses, we use 2x6 walls for wall studs. This allows for a little bit more insulation to go in there, so it is a little bit more energy efficient. These houses are about 255 square feet in total size. So this is built a little bit differently. Once we go inside the actual tiny house, you'll be able to see what I was talking about with the staggered stud system, creating the inside and the outside wall cavities. I think we're just going to go into the main house. Okay. Okay, perfect. So the first thing we kind of look at, we talked about energy efficient windows, energy efficient doors, and then also the exterior of the house. So we used Alpine windows. That's what they chose to use. And I'm off the cuff, I was thinking these are at R6 value, where a lot of your windows are only at about an R3, so it's double the insulation value. The front door itself is around an R6 as well. This was a special ordered item. And then the back sliding door is a special door as well. It is actually up at an R10, which is one of the highest value doors that you can get. You also pay for that, obviously. It came from, I believe it was Germany, and it weighed about 2,000 pounds within the crate itself. So the glass, if you look very closely at it, is about an inch and a half thick. There's 3 panes in there. So it is a very heavy door, very substantial, but it also reaches the R value, which is one of the highest on the market. So, and then we'll go inside. Be careful on the staircase here. So we can go inside the house itself. We can see some of the features that are inside with the exterior wall itself. And so the example, So from the inside of the house here, we can see a couple things within our walls. We already have a layer of what's called polyiso insulation. Everybody's probably familiar with the traditional, what we call bad insulation. That's the stuff that gets, if you've ever messed with it, is really itchy, has fiberglass and things like that in it. It's really soft, comes in rolls. This is a foam polyiso insulation, which is actually a lot more denser than typical even styrofoam rigid insulation. So this has a higher R value. So that's why we chose to use it in the walls itself. The inner cavity has already been insulated because there's no actual utilities that need to run through there. There was no electrical conduits or anything. We're doing that on the inside cavity. So you can see our wiring and thing is run through the inside cavity. And then once this is completed, we will actually add another layer of insulation, creating the actual thermal break again. So there's a couple different thermal breaks that we've created within our wall system. The other thing that you're going to notice is that there's kind of a blue silicone or a blue caulking that's all the way around that we do in these cavities. That is to help seal the airspace in there. So that way there's no way for air penetration to go in and out of our walls. So once we put the second layer of insulation on here, that again will be sealed a second time as well to help prevent air loss. There's been talk about doing like a vacuum test within the house itself to see the pressurization, to see if there's any actual air leaks at the very tail end of this. So that's kind of the point of that. You will also notice then that there are studs that are kind of hidden back in there when you walk through here. The other portion of this, then we talked about heating and cooling using more energy efficient appliances. What you see up here up above, for those of you who have probably not seen that, if you've been out to the Front Range in Colorado, you've probably seen these in a lot of houses because they have them out there. These are called mini splits. That is essentially a heat pump, which heats and cools your house. And it runs a little bit more energy efficient than your traditional furnaces. Doesn't use any kind of gas like your traditional furnaces and things like that. Also, it is considered ductless. So I consider it something very similar to like what you see in your motel rooms. When you walk in, you can heat and cool it. So it just blows air directly in the airspace. Other features that are not actually in here yet is that Dr. Chen is going to use what we call basically like a thermal storage system underneath the house. So in the crawl space itself, he wants to set up a duct system that's going to take the existing air, kind of like a typical supply and return that we have with a traditional system. It will take the used air that's hot, that has rose to the top, and it will run down a duct system that will go down into the crawl space down below. And there are concrete blocks and things like that that will actually transfer and store the heat that was used within the house. So that's just another element of this. Also, then we have, how do we recycle the air when we're using a ductless system? We have what's called an ERV, which is an energy recovery system. That is actually mounted. It's the silver box that you see on the second wall behind you there. It is not running any duct yet. Our HVAC team has not quite made it there yet. But that is what we call an energy recovery system. It is going to recycle and bring in fresh air. So it will bring in fresh air from the outside and help create a fresh air space within the house itself, which a traditional system does already for you. You just probably don't realize it. So the solar system itself, obviously you can't really see that. You got a picture of it. The boxes that you see in the back over there, the solar system works in DC power, and your house is powered through AC current. So what we have against the wall over there next to the electrical panel, which is the back wall, the side wall over there that we can see perfectly from here, that is called an inverter. And that is basically a big conversion unit. It's converting the DC current that's gathering up above and then converting it to AC power that you can use within your house. So the R values, I guess I could talk about that a little bit too as well. So we talked about R values. That is just how we rate our insulation. The typical wall here in Nebraska is R11 to I think R19. These walls, when they're done, will be at a R50. So it's essentially over twice the amount that's required by code. And typically we see about an R50 to an R60 within our ceilings and our floor systems to insulate there. And we're going to be at an R100 value. So they're doing it twice as much as it's required by the current code that we see here in Omaha. Other features, we can't really see that just yet. So that's kind of where I'm at with this. Just feel free to kind of roam around if you have any questions. I can answer any questions. I don't know if we had anything more formal. Sure.
How did the mini splits hold up to Nebraska winters? We used to have it in our Florida house, and then moving up here, we're kind of advised against putting them in our home.
So the units, I don't know how long ago that was. So the question was, how do the mini splits hold up in our Nebraska environment? Somebody here had asked because they used to live in Florida, that maybe they're not as conducive as here. The heat pumps actually have been used here. So the older style heat pumps I know that were 15, 20 years old in houses that I've been involved with tearing those out, they were not as successful, but modern technology has brought these a long ways. Earlier, I mentioned that you see these a lot along the Front Range in Colorado. Colorado has been a front runner in this kind of concepts and building. And so they have a lot more, they're kind of like California. There's California and Colorado. So a lot of houses in the Front Range of Colorado, because they're semi-temperament in the Front Range, did not have air conditioners and things like that in their houses. So they started using mini splits. So they work really well along the Front Range, where they do have weather very similar to ours. They can get 15 inches of snow and then turn around the next day and it's 60 degrees, just like we have here. So the Front Range is very similar, I think, as to what we experience here. They do get negative degree temperatures and things like that as well. So the other nice thing is if you have an older house that maybe doesn't have the traditional systems, like back in the day, they used to have boiler systems and fireplaces, and that's how they heated their houses. You can retrofit and use those as well. So I think technology is catching up to answer your question.
And the key to it is the building envelope, right, Corey?
Right.
You have a sealed building envelope, if you're controlling the fresh air in the house, mini split would be a great solution.
Right.
The challenge here is we have many older homes with a lot of air leakage. The mini split can't keep up because it's losing that air.
Right. So, through the windows, through the seals that you don't have, that we have actually built behind the windows. So that kind of thing. Very good, Nate. Yep.
What's the square foot of this?
So the footprint is about 600 square feet. So what we could have done, this was designed as an experiment, right? So that back room back there is considered a maintenance room or mechanical room. Originally, it was going to hold the cisterns and things like that, but then we realized that they needed to be much bigger. So that could essentially be turned into a bedroom. So it's essentially the size of a 600 square foot, 1-bedroom apartment, essentially. Where everybody's standing right here is going to be the kitchenette. So along that wall, you see the plumbing pipes and things like that coming down. That's where the counter is going to go, the sink, and then the refrigerator and the stove and stuff like that. And then this is considered the living space. The intent is that they have a Murphy bed. I think they've actually kind of ironed out that they're going to use. And they'll have a Murphy bed system that's going to mount directly to this wall right here. And so the bed can go up and down. So then they can still have a couch and everything out here and have essentially a living room and drop down and be a bedroom as well. So if they got rid of the maintenance room, they could do that or just convert that. Hindsight's 2020. We realized, but it was too late. It was kind of like, let's just leave it. It's an experiment for now, which that doesn't mean you can't change it to a bedroom later. And it's perfectly good size to be a bedroom. So,
and if you look at the roofing system, you might notice it's been overbuilt. But again, the whole idea of this granite pod specifically is to extend, the living of people. So if there ever needs to be a mobility or a hospital, I guess I don't know what you would call it.
Yeah, and I'm
transfer people from the bed to a bathroom. It's built for that kind of structural ability.
Right, and I'm having a brain fire right now too, there is an actual lift system. So, and I didn't think about that, but if you'll notice right up here, typically you can put your rafters and things on 2 foot on center. We're at 1 foot on center. And the intent was that we could set up a chair lift system that if they needed to come over and they were bedridden, essentially, and can't even get into a wheelchair, they could get into the lift system, and then it would take them directly through into the bathroom and right to the shower. So we, ahead of time, tried to accommodate that for future, for if they want to add that. So,
I have a question.
yes.
Okay, so you've got the solar roof. You don't have any utility history to know what
Right,
you need to
not
model
just
it
yet.
as. But just guessing what percentage of the electrical usage is it supposed to cover? Is it supposed to cover 100%?
It will be 100%. And the design, if I remember right, it's been a while since I talked to Michael, who's the one that kind of came up with the system, but I think it's a 14 kilowatt system, which should be more than sufficient. It actually will overpower what we need here by a little bit. So when we talk about that, you can either set up battery systems and be 100% on your own. What a lot of people are doing when they're converting to solar now is they call it feeding back into the grid. In which, so if you're here in Omaha, OPPD just comes out, they inspect the meter to monitor the transference. And then they don't offer you the retail credit. So it goes back into the system. So maybe during the peak, when you're in the summer, when you have most daylight hours, you're bringing in a lot more power than you need. And then during the winter hours, when you have a lot less daylight, those credits then power your house essentially. Which if you have a battery system backup, same thing. It's just eliminating the cost of the batteries. So, and it helps feed the grid. So those are kind of the two options there. And yes, it's designed to be a net zero house.
And so then obviously the stove and stuff will be electric.
Yes. And the water heater is electric. And they're actually setting up where it has a little different system. So it has an actual like fan that kicks out cool air. There's some of those systems do that, and they're going to reuse that and duct it into the space as well. So during the summer months, that cool air that's coming from the water heater will actually help adjust the temperature in the house. And then during the winter months, it'll have a damper. So it'll divert it and just send it straight outside. So you're not making your house colder. So. And just feel free to kind of walk through. The only way to get into the back room is you have to come down the stairs and you'll have to come back up in. But the inverter and the electrical box is in there. There's no live electricity in here except for the lights that we were kind enough to set up earlier. So, yeah. Yeah. Yeah, my aunt has
I'm interested in the lower windows.
the flow, the airflow. It has to, yeah.
So
So
you can actually ventilate.
yeah. So the idea was the intent of the high up and then, yeah, allowing.
I didn't see that up there.
Yeah. And the intent is that those are all going to be automated at the end. So we actually have motor controls that haven't been set just yet. But each one of these, they'll be able to hook up to Alexa and just be like, Alexa, 50%. Yep. Yep. So. Yeah, everything has been like high end, like thinking technology and that kind of thing, and his intentions behind this. So. And as soon as he approached us, I jumped on it. I was like, this is awesome. And so, right. And that's what it's been for our students. It's kind of like, this is the first of its kind. So when the questions come in, what are we doing for the curriculum and stuff? It's all in development. Like this is, we're just bringing this to our program. There's only one other community college I know of.
Somebody to come out with thermal imaging cameras, that would be really cool. And if you can do a flow door test, that would be really cool.
Yes, that's what we're looking to do. Oh, yes.
Do you plan on putting ceiling fans in the house?
Yes. Yes, we do have a ceiling fan that is intended to be in the house. And the actual brand name is Big Ass Fans. So that is actually what the brand name is. And yes, there will be a central fan in the house itself. So.
Thank you so much for joining us tonight. We will see you again very soon for the next edition of our Hubbard Sustainability Series. Thank you so much, and this will be posted online for you to enjoy later and share with others. Have a good evening.